we need to prove the following. So we'll start from the left hand side. Here we have 1 minus, now we have sine squared divided by 1 plus cotangent of theta. So in the second term, we're going to multiply both numerator and the denominator with sine theta. So we have sine theta times sine squared theta, that gives us sine cube theta in the numerator, divided by, we have 1 plus cotangent of theta. Sine theta times 1 will be sine theta. Sine theta multiplied to cotangent of theta, that will be equals to cosine theta. That's because cotangent of theta, this is the ratio of the cosine to that of the sine function. That means we have cosine theta over sine theta. So when you multiply both sides with sine theta, we have cotangent of theta times sine theta will be equals to cosine theta. Now coming to this third term, we're going to multiply both numerator and the denominator with cosine theta. So we have cosine theta times cosine squared theta, giving us cosine cube theta in the numerator, divided by, now we have cosine theta multiplied to 1 plus tangent of theta. So that should give us cosine of theta plus sine theta. That's because tangent of theta is the ratio sine over cosine. Which means if we multiply both sides with cosine theta, we're going to get tangent of theta times cosine of theta equals sine theta. Now what we'll do, we'll combine the second and the third term. So let's combine them. So we have a common denominator of sine theta times cosine theta. In the numerator, we're going to have sine cubed theta plus cosine cubed theta. Now we will be using here an identity, a cube plus b cube. When you expand this will be equivalent to the product of a plus b times a squared minus ab plus b squared. So in the case, we're going to consider a to be equivalent to sine theta and b to be equivalent to cosine theta. So let's use this, and that means in our numerator of the second term, we're going to have sine theta plus cosine theta whole multiplied to sine squared theta, that's a squared, plus b squared will be cosine squared theta minus a times b, so that's sine theta times cosine theta whole divided by sine theta times cosine theta. Now, sine theta plus cosine theta will get factored out from the numerator and the denominator, and we know that sine squared theta plus cosine squared theta, this is an identity. This value is equals to 1. So we have 1 minus sine theta times cosine theta, and this is going to give us sine theta times cosine theta, which is the expression on the right hand side. Hence we have successfully showed that the left hand side is equals to the right hand side, hence proved.